Hello, we are GroupGen, and our project is about Bitcoin Trust Network Analysis. Bitcoin is a cryptocurrency which is used for worldwide payment system. The network is peer-to-peer and transactions takes place between the users directly. These transactions are verified by network nodes through the use of cryptography. The dataset we used has 3,783 nodes and 24,186 edges. It is a signed who trust whom network of people who trade using Bitcoin on a platform called Bitcoin Alpha. Members of Bitcoin Alpha rate other members on a scale of -10 to +10, where -10 is total distrust and +10 is total trust. From the degree distribution plot, we can see that it's a kind of power law distribution, indicating sparsely connected network in the real world. Older users that entered the transaction market earlier have more edges on average, and they prefer to attach to nodes with many connections. When looking at the results of triad census, one type caught your eye: the frequency of the 11th census, which only explains reciprocal connections between 2 over 3 of users, is very high when comparing to the other types. It brought a question to us. Since this kind of connection is pretty common, are we able to predict the relationship between these two people in this triad who have not connected yet based on the information of existing edges? A good news is that we have sufficient data of relations in complete triads like type 9 and from 12 to 16. This can help us figure out this question. Based on what information we have, we try to build regression to predict the weighted relationship. Other questions we try to answer are: how well can we predict the relationship between these two people in this triad who have not connected yet based on the information of existing edges? Does a larger network in a similar pattern help predicting? And how can we fit in the network when we first get into the transaction market? To address this question, we build a linear regression. Suppose we have three nodes A, B, and C, then we can calculate the strength from A to C using the calculation shown on this slide. This is the dataset we use to generate the regression model. We start from three columns, which are the ID of the ego node, the ID of the alternative node, and the strength. Then we use SQL to join the table. Based on the regression, we found that the adjusted R square for a group of 4 is lower than for a group of 3, and it would keep decreasing if we build a similar model for a group of 5. It tells us that a larger network in a similar pattern could not offer more predictive power. After running some basic statistics to compare the group of 3 and 4, the result matches what we found in the regression models. To make a better prediction, we can use binding for the independent variable or for the dependent variable to increase the adjusted R square or the AUC. And we can keep adding some attributes of nodes or some statistics about the strength into regression formula. But by now we already have some conclusions. Suppose there are four people in the network A, B, C, and D. Then A knows B, B knows C, C knows G, but A doesn't know C and B doesn't know D, which means there is no subnetwork in this group of four. Then the trust from A to D would be weak and not easy to predict. The relation from A to D would improve if A knows C first or B knows D first, which means they form a subnetwork of three people. This is an example that A knows C previously, then it would increase the trust from A to D. We can conclude that the network follows a power law distribution and the correlation between eigenvector and between its centrality is relatively low. When we first enter the network and are not able to connect with users with highest degrees, we can try to find those with high eigenvector and ask them to help us introduce. Based on what we found in the prediction part, the strength of trust from high degree user to us would be more predictable, stable, and powerful than when we are introduced by someone that the high degree user has no connection to. And if we fail to build connections with these users, we can connect to those users with high goodness. They might not be able to introduce us to a lot of users, but at least we can have a satisfying transaction with them and can enlarge our network slowly. Thank you.